So I welcome you to the lecture series on practical image processing using OpenCV Python and myself Dr. Dibya Bora. Well, today our topic is detecting phases using HaarCascade in OpenCV and Python. I hope you already know that this is a very important topic as maximum of you may going to execute this one for your projects. Okay, so this is our first lecture on phase detection using HaarCascade. Okay, so let's start. First, this will be our code. You can take a screenshot of this. Okay, first take a screenshot of this so that you can perform it by your own. Now I am going to explain each statement. So, face detection using HaarCascade is a machine learning based approach where a cascade function is trained with a set of input data. So, our HaarCascade is nothing but a machine learning based approach, and we are going to use a cascade function for our input data. And OpenCV already contains many such pre-trained classifiers for like face, eyes, smiles, etc. Okay. And now today we will be using face classifier. For each of them, that is eyes, smiles, I'll try to frame different lectures so that you don't need to worry. Now this lecture, I'm going to use face classifier. Well, for that, you need to download one XML file, and that you will find in our GitHub repository. I'll give the link in the description box so that you can easily download it. Well, we are going to need it, and the file that I am going to use for this lecture is HaarCascade underscore frontal face underscore default.xml. Please download it through the given link in the description box. Okay. Now, detection works only on grayscale images. You have to note down. So it is important to convert the color image to grayscale first. And so means you don't need to worry. Actually, we are going to detect on color image, but first we are going to convert it into grayscale image. Then next point is that detect multi-scale. Detect multi-scale. This is a function that will be used to detect the faces, and it is going to take three arguments. That is detect multi-face, multi-scale function has three arguments. First input image, then scale factor, then mean neighbors. Input image, that image you are going to input. Okay, then what is scale factor? Scale factor specifies how much the image size is reduced with each scale. How much the image size is reduced with each scale. Then mean neighbors specifies how many neighbors each candidate rectangle should have to retain it. And I know you guys are all aware with what is neighbor. I have already explained in my previous lectures, one of my previous lectures about neighbor. So you see now the practical use of neighbor. So three parameters or three arguments: input image, scale factor, and mean neighbor in detect multi-scale, where M capital, S capital. Clear? Then faces contains a list of coordinates for the rectangular regions where faces were found. Do remember that actually we are working on the coordinates of the rectangular regions, and we use these coordinates to draw the rectangles in our image. Okay, so the output image will be for the linear image is this one. You see this rectangle. So the face is well recognized in this example, because in this example I am considering linear image. So after going through this code, see import cv2, then to create a cascade classifier object, face cascade, cv2 cascade classifier, then keep the path where your xml file will be there. Do important that many times students used to tell me that we are getting an error, because my dear, you need to give the exact path where your this xml file, that's HaarCascade frontal face xml file will be there. Okay, this one is for my laptop, but your storage location you have to specify, and you are going to download this file first from the default, from the link I am giving in the description box. Okay, clear? Then reading the image, so image CV to imread, this is the part of the linear image. Then we are going to convert it into grayscale by CV to CVT color image. Okay, CVT color image, CVT color BGR to gray, color underscore BGR to gray. So the image will be converted into gray, and this will be stored in this gray variable. Okay, then detect faces, face cascade detect multi-scale, you know, 3 inputs. So gray, this is the input image. Then 1.1 4, what is 1.1 and 1.4? You have seen that 1.1 is our scale factor and mean neighbors is the third parameter, third argument. Clear? So gray 1.14. Then draw rectangle around the faces. So for that I need to give the coordinates. So for x, y, w, h in faces, CV2 rectangle image x, y, then x plus w, y plus h, then up to 255, 0, 0, then 2. Clear? So then display the output by CV2, so image, then CV2 wait key. So image will be, our output image will be displayed. So first let's open your in Spider, or that Python ID you are using. I'm using Spider, so I'm going to open it. So please open. I have opened my Spider. So you have seen that these are the codes that just I have explained. I have explained each statement of this file. I am saving it as paste recoc1.py. So you can save it by your own suitable identifier. So let's execute it. So I'm executing this, this control part is there executed. Now let's display the output image. See, the output image is coming. You'll see the linear image face is well recognized through this face recognition using HaarCascade algorithm. Okay, so I hope these all statements are clear to you. Now you can apply it in your project. And see, this is the first lecture. I'll bring more lectures on face detection and face recognition in OpenCV. So for today, I think that's enough. Thank you for your attention. But please, one question for you. And today's question is that how many arguments you need to provide in detect multiscale function? So please answer the question through comment. Okay, and also tell me that what that is argument will work, means what that argument will do for you in the detect multiscale function. So I'm terminating today's lecture. Thank you for your attention. Take care. Bye bye.